Hello, everyone. Good morning, good afternoon, wherever you are in the world. Welcome to our webinar. I'm just going to put this so we're a little more straight on. As most of you know, my name is Monica McMahon. I'm here with Daniel Tan, and we also have Ryan Houston on the line, and we are here to troubleshoot your PCAP files. So before we get started, we're just going to put up a quick poll here. It's helpful for us to know what most of your roles are. It helps us kind of figure out what angle we should be troubleshooting from. So are you a salesperson trying to figure out how the heck this works? Are you a technician trying to solve a problem on one of your sites? Are you tech support, getting all these files all the time and trying to help the guys out in the field? Controls engineer, IT professional, or something entirely different. So if something else, feel free to fill it in the chat and let us know, and that will help us. So I'll give you a quick moment to fill that in. All right, we have 80% of you voted. Let's get a few more. Okay, awesome. Thank you so much. So we've got a lot of controls engineers, tech support, and technicians. So all you hands-on people, that's really, really awesome. And we'll just do a quick, a second poll here. I want to get a bit of an idea of how many of you actually have Visual BACnet accounts. So if you could fill that in. And while I'm waiting for you to fill that in, I will also mention that we have 3 files that we're going to go through today. We just had someone submit one last minute, so that's really awesome. If you have a file that you want us to get through, I believe last webinar we got through about 4 files. I think we did a quick 2 minutes on the 5th file. So we do have space for 1 more file, depending how quickly we get through these ones. So if you have some you want to submit, the best way to do that is to share them with demo@optigo.net. So I will put that in the chat quickly. Ooh, better spell it right. That would be embarrassing. And then we will, and let us know in the chat and we'll get to them. So, Daniel,
yes.
Are you ready?
Yes, let's go.
Ryan, are you ready?
I'm ready.
Okay, we have no video on Ryan today, but that's okay. Oh, all right. So I will quickly share my screen. Okay, here we go. All right, I believe everyone can see my screen. If you can't, let me know. So we are going to start with the file that we didn't have time to get to last week. It's a middle school file submitted by Jake. Thank you, Jake. I'm not sure if Jake is online. Let's see here. He's not online yet, so we can't ask him too many questions. But I do know that this is from a troublesome middle school. And that's really all we have to go. And I also know that there's some analytics on, there's an analytics system on this network, and it's been pulling some data. So that was one of the things they were interested in seeing, the impact of that. So take a look. I typically start by going right into clicking on the network health. We're at 58%. Ryan or Daniel?
So one thing that jump out here is missing acts for sure, and also reject to networks. So I would usually go and take a look at reject to networks first. So network 7051, there are almost 1,500 packets with reject that's saying that that is rejecting message to this network. So
and that's in about 46 minutes.
Mm-hmm.
So
that is a lot. So devices are trying to reach this network, and the router to this network is saying that something is not right, and the reject error seems to be other, which doesn't describe much.
Not entirely helpful. Other error.
Yep.
So this this device is online because it's sending the reject. So it's not that it's offline, right? Mm-hmm. It's just that it's sending a reject notification.
Yeah.
And they all seem to be other.
So the next thing here would be to look at the acts.
Okay. So we'll go back. Missing acknowledgements. So 22% of the acknowledgements are missing.
And the
Oh,
and the majority of them are coming from
So
source 3011.
look at this information. When you look at your rejected network, the 172.19.55.41 is the same device. So it's odds are you've got a problem with that device.
yeah. So it's not acknowledged. So likely, if it's not acknowledging and it's sending the rejections, it's online. It's functioning in some way. So likely it's overloaded, I would say.
It could just be failing. Device 77051 definitely has an issue.
Yeah. Okay. And that, yeah, so that's, we don't have a vendor attached to that one in this case. And then these two far less unacknowledged files. Not enough to keep you up at night, likely. Okay.
And the subscribe COV for the last one.
Yeah. Oh, we're just loading here.
So you might want to take a look at that subscribe COV because it looks quite regular. That all of them are not getting an acknowledgement. There might be something wrong with that. The device trying to subscribe COV.
It's either that or it doesn't support it.
Yeah, so something between these two, it's consistently not acknowledging the subscribe COV. So make sure it's supported, make sure that it's set up, configured correctly.
So there's a list in most BACnet controllers showing what services it supports. So this would be the time to go into your BACnet system and verify if it's even allowed to handle that service choice.
That would explain it if it's not. Okay, so the combination of the rejects and the missing acts makes us think that this one device, which is device ID 7051, IP address 172.19.55.41. Back in here, let's see if there's anything else.
If you want to look at error responses, less than 1%, but we can see what's causing these error responses.
So it's all that same device.
Going to the same destination. It's the same problem again. So a lot of this files around this one device.
This is the same one that I just read out, correct? I can't
Correct.
remember. Yeah. Already forgotten it. Yeah.
It's the read property request, and if you look at the error,
APDU.
So it's an unknown property. And if you look at the request, you should see what property is trying to get. So APDU timeout property.
So it's requesting the APDU timeout and it's responding with errors. And is that consistent here, I wonder? Yeah. So
it's requesting for an unknown property from from 32.11.
Okay.
So 55.41 is requesting for APDU timeout property, but 32.11 does not have that property.
Doesn't have it. Okay.
If you just fix, there's a programming fix for this.
Okay. So it really is all coming back to this one device. Okay. Let me just check if we have any questions. Anyone confused? So far, so good. Anything else that we should be looking at in here? So we've got some 77 global whois. Seems like quite a lot.
Look at the longest.
40-second response time. That's almost a record in a not good way. And it's the same too.
55.41.
Yeah. So it's all that same device, and it's those unsubscribed COVs as well. So go look at that guy. See what he's doing. Jake was online. Tell us what it was.
So again, this is a case where that 55.41 is asking for information from 32.11, and it's taking an awful long time to get the information, and the information it's getting, it doesn't actually support. So what you've got is this little circle back and forth saying, I keep wanting this information, and you're asking for it over and over and over, and it's telling you it doesn't support it over and over and over. And then it just goes around and around and around. And now the response time most likely is because of all the requests and the rejects, it's just getting longer and longer to respond.
So it's almost a minute. The rest look good,
Yeah.
so it's just that one. So I think most of the problems are being caused by that one device. Global Whois. So 77 Global Whois in 46 minutes. That's more than one a minute. So likely this source is the server. This problem one is the server, which makes things all a lot harder, I would guess. So
That's a global Whois from the lowest to the highest.
okay.
And then let's check the second. It's the same. Right. So can say for sure that all this 55.41 is just sending global Whois every two seconds.
It's not really consistent though, because 43 to 46, 47, 47, 49, 49, 50, 52, 52. So yeah, 2-ish seconds, but also changing a bit. And it's not segmenting them. It's not saying 0 to 99, 100 to 199, which is a best practice so that you don't take down your entire network.
And this is sending way too frequent.
Yeah.
It's asking for the whole entire range of the network.
Every 2 seconds, actually like twice every 2 seconds, so, or more. So a lot of unnecessary traffic. I know there are some devices, depending on the vendor, that have it set so that they send it every minute, which is already too often. But this should be something that you can reconfigure. It shouldn't be a preset. So
there's many cases in a global Whois, and the first case is looking for all the controllers in the entire range. So normally when you bring up a system, as many of you know, then you do a scan of the network and you bring all of the controllers into your front end system. However, there are sometimes implementations of the global Whois that in order to make sure your network is updated constantly and you have the right controllers, then it will do that consistently. And when you have a small network, you could get away with that, but the bigger the network gets, you get constant network traffic, which is unnecessary, and it starts to overload all of your systems, because every time you send a global Whois request out, you're expecting a response back, such as an I am here. So now we're talking about 4.2 million packets, right? That's what it's looking for, and you can potentially get those back. So it's good practice to not do this. You'll see in many other BACnet implementations where in this range you'll see a 0 to 10 or a 0 to 100 and then a 101 to another number. And what that's doing is it knows where the controllers are and it's looking for the gaps within to see if something new came. And it's in that regard, that's software approach to making sure your list is updated. And it's all about the positioning and how these things are done. In this particular case, this isn't good. And the bigger you grow this site, the worse it's going to get.
okay, so Jake is online, and I've got a little more information about this 172.19.55.41. It's a global controller. It's one of their global controllers, so it seems, Jake, just for your information, it seems like it's all of the issues are coming back to that global controller, and it sending rejections and errors and way too many global Whois, causing a lot of traffic on the network. Anything else to add to that now that we know that it's a global controller? Ryan or Daniel?
I don't think so. It's possible that the controller is doing too much work. So you have to see kind of what its scan rate is and see if it can do what you're asking it to do.
All right. I think that's most of the information on this file. We went through most of the failed diagnostics. There's quite a bit of RAID property traffic, so maybe something to look at trying to reduce, but it's not being hugely problematic. Although it's all this one object. So that's a bit weird.
The global controller is asking for the device instance.
Oh, okay, that's what this is, device. It means it's looking for the device instance of this guy, 172.33.32.11.
So it's asking for what services are supported.
And it's always asking for that.
Every couple seconds. Something to consider the configuration of, because it should not be doing that. And that will likely reduce your packets from 3,000 to 4. So that could be good. Okay.
Well, I think Jake knows what to do now, so he knows where the devices are.
It was also a brand new device, so hopefully that will be some help. And he's not sure what that device is, so good luck, Jake. Hopefully that's helpful, and if you do some work on it, we will take a look at your next file on the next webinar. All right. So I don't see any other questions on that file, so if you do have a question, let us know. Otherwise, we are going to move on to a new file, to a university file. And again, I meant to show this earlier. There's this little share by email button. So if you have a file in your Visual BACnet account, for those of you that do have an account, feel free to just click that share by email button, share it with demo@optigo.net, and we can hopefully take a look at it after. Otherwise, you can email it to monica@optigo.net. Let us know in the chat, and I'll go quickly grab it. All right, so this university has a network health of 0%. This is one of many capture locations that they have, and they actually do monitoring on it. So this is their most recent file that they've shared. So lots of things to play with when you have 0%, and I don't think any of us have really looked at this. So here we go.
Let's step back to the graph. That was pretty impressive.
Ooh.
We have BACnet and non-BACnet.
So BACnet, non-BACnet, we've got some huge non-BACnet spikes. So something to be aware of, although maybe not something you have a ton of control over. We're getting spikes up to 600 packets per second.
Every 5 minutes or so.
Yeah, consistently. Not a consistent number of packets. Actually, yeah, it's kind of like a...
It's pretty consistent, and you've got a pretty consistent packet floor of 200 packets per second. Yeah. So this is a really busy network.
Yeah. I'm just going to see, Mike is online. So Mike, if there's anything you want to add about this network, this is Mike's network, let us know. Feel free to pipe in there.
So let's just give some reference to this. There's 1,200, almost 1,200 devices that we observe on this network, and you have all of this packet information going by. So imagine there's a lot of networks out there that are 5, 6, 7,000 devices. And if you grew it to that scale, it would fail. It would not communicate. So this is where you really want to make sure you have a healthy, clean network to be able to expand.
Yep. Okay. Are you ready? Circular network. Oh, let's see. Mike has a comment. Mike says we're working on that, Ryan. I added the Ryan.
I know you are. I know you are.
That's why we're here. I'm guessing. Okay, so circular network. This is always an interesting one for us because circular networks are crazy. So for some reference for everyone who's listening, the way that we find a circular network in Visual BACnet is we look at the hop count. So based on the BACnet standard, every single device when it sends a packet, the hop count should be 255. And then every time it goes through a router, that router knocks off one number, so it's 254, 253. Most packets won't go through more than a couple routers, maybe 10 in a really crazy scenario. So it's very rare to have a packet count less than 245. Some vendors or devices by some vendors, there's some specific ones that they've really are violating the standard, but their device has a hop count of 15. Is that right?
Yes.
Which is 15. Yeah. So which is 4 bits instead of 8 bits.
That's right. So half a byte instead of a full byte.
Yes. Okay. Daniel's the expert. I'm just the mouthpiece. And so occasionally you'll get a low hop count, so a hop count of 15, 14, 13, 12 from a device that is violating the standard. So we look at a low hop count, and I believe we look at values less than 10. So we have a low hop count check, which is anything, I think, in the 14, 13 range. Yeah. And then so on a circular network, what happens, and we do have a 10-minute webinar on this that we'll send out later, but the packet goes around and around and around so many times so quickly that the hop count goes from 255 to 0 like that. And so we look for hop counts of 0 or 1. However, occasionally there's weird scenarios that flag that cause a bizarre hop count and flag the circular network. So it's one you have to be really careful of. If you have it, it's a huge problem, but it does get flagged sometimes incorrectly.
So I'm actually not sure about this one, because the network seems to, there's a lot of communication going on to say that there's a circular network involved in this network. And what do you think?
Right, because the circular network takes down everything pretty much.
It takes it down in a particular segment potentially, but this one's interesting where the destination's the same in all 4 cases.
Mm-hmm.
Right. Yes.
Does Mike have any information to add on this?
Mike, any ideas? Let's see. Not so far. We can maybe typing. It doesn't. So the other thing that I'm noticing is that it doesn't. Oh, so the destination is it's a front end. Also, often if you have a circular network, you can see the. Correct me if I'm wrong, but you see the frames here with the hop count decreasing. No?
What are the sources? Are they routers?
That's a Mike question. We'll find out soon.
Or do you have multiple network cards coming into that front end?
Ooh, that does sound familiar. All right, well, so Mike, we're trying to figure out, sorry, Mike asked us to ask again. So we're trying to figure out what those 4 sources are, the 10.120s. So they're all going into, the destination is a front end, but what's, he says, yeah, there are 100+ networks. And so are those routers? He's looking. All right.
So there's a potential here which happens in BACnet IP and BACnet Ethernet. It's very easy to turn both protocols on typically in many BACnet systems, as simple as a checkbox. So it could be a case of what's happening here, or it could be, it's possible that if there's multiple network cards on there, then they're somehow they're routing together. So that would be interesting to dig into that for a bit more information.
Okay, so it's likely not a physical IP Ethernet duplicate circular network.
It's probably more a logical problem of some sort.
Yeah, what kind of logical?
Well, while we get some more information, let's go take a look at one of the other errors.
All right. There's one or two more. Okay, so then we have 3 unresponsive routers. Let's take a look at these. Network 1, network 16, and network 1001. They're all 100% unresponsive. Okay, that looks like is that the same? Okay.
These are all on BBMD.
Oh, they're all forwarded.
It's looking for it every 20 seconds and then 10 seconds, 20 seconds, 10
Oh, that's a fun pattern.
seconds.
Yeah. So 0, 20, 30, 50, 0, 20, 30, 50.
So if the network should exist or it should be up, then check the router to that network. Otherwise, the source is configured wrongly to look for the network.
Yeah. So hopefully you have a network list and you know if networks 1, 16, and 1001 should all exist. And if they should, then then they are having some problems.
Hey, Daniel, answer me this. If this is just throwing a question out there, if this is a BBMD network that it's looking for and the network's on the other side of the BBMD, this is potentially an IT problem, would it not be?
An IT problem. It is on the other side of the BBMD. But it would be broadcasted. The who is routed to network and I am routed to network should be broadcasted. So if the IP network is set up correctly, it should reach all of the routers.
So we're saying it has done that. It's just looking for something that doesn't exist.
Either doesn't exist or the router to that network is not up.
Okay, so Mike's saying that these networks are not in our inventory. So I'm guessing all 3 of them are not in the inventory. So likely what's happening is this device, 10.120.24.10, is misconfigured to try and talk to networks 1, 16, and 1001. So that device is a BBMD. So actually what's happening is a device underneath that BBMD underneath those BBMDs are trying to talk to these networks.
So there's some old data left in there, either old programming or old graphics requests, something that's trying to get data. And it says the data's, I know it's over here somewhere on this network, and then that network doesn't exist.
So it says, I know that network 1001 has this data, sends it to the BBMD, BBMD forwards it, says who's the router to network 1001, doesn't get a response. So it's going to be a device, and all 3 of these
2 different devices.
So it's going to be 2 different devices that are under these BBMDs. So the BBMDs of the source address. So likely it's not the actual source, it's the device underneath it, correct?
Yeah.
Okay. So Mike's saying we don't understand why there are requests for them. It's possible that they used to exist at some point, although you probably know that better than I do. Or it might be a preset, like especially 1 and 1001, maybe presets that never got wiped out when you were configuring.
There's another way we might be able to look at this is if we look at the unresponsive devices, because someone's going to ask for its information. So we can verify in that list, it's fairly short, that you can determine which one is the problem.
Okay. Triangulate this issue.
There you go.
So we will have to go into here to figure out which.
Check the APD, it should show you what it's looking for.
But we want to figure out the network number, right?
We wouldn't be able to get it from unresponsive devices. because it doesn't know which network it's on in the first place. Unless we get a IAM response.
Go to the BACnet browser. No, because there's no devices on that network. So we're trying to see who is talking to network 16. These devices, and these devices are not responding.
So try BACnet browser.
Okay. So DNet is
16.
Oh my gosh. Ah, 16.
Service choice. It's always routed to network. So all the traffic going to network 16 is just who is routed to network.
From this device.
Source, yeah.
So 10.120.24.10 is sending who is routed to network 16. So there's no device underneath it. No, there would still be a device.
What that's telling us is in this capture, this is as much information as we have. If we captured in a different location, we may be able to see more information.
Yeah, so if you capture under that router or controller, or be under the BBMD, you may be able to find out more information. Depending how many devices are under that BBMD as well. If you have thousands, do a capture and we can figure it out. If you have 2, go check them out. I'm guessing based on this network, you have thousands. Let's see. Oh, it's an NAE. Okay.
So one thing that helps us, and it'll help yourself troubleshoot a lot, is when you're taking when you take a look at this, if you have an updated network drawing, or at least a portion of it, it helps us trace where it's going, so we have a better idea. I mean, we're going to have a certain amount of information, and we can tell you that here's a source and it's going to this location, but you guys out there are going to have a better idea of what's actually happening based on your sites, and it goes a long, long way that you can actually trace the route.
Mm-hmm. Yeah. Otherwise, you're going to get to a situation like this where you go, okay, it's all coming from this BBMD, it's underneath, now I have to go capture there. So, I mean, you may still end up doing that, but the more you know about where it's coming from, then you can kind of go, oh, these paths all have trouble and they all go through this same device. Okay, so something underneath that NAE is causing problems. These unresponsive devices, oh boy. So you'll notice that there's 131 entries here, although there are 38 on the last screen, and that is because as we get to the 39th device, you'll see that they're not 100% unresponsive. So this one answer in our 2.5 hours, it answered one of the 2,218 packets that was sent to it. So as you get further on, you'll see some that are 50 and probably 6% unanswered. So definitely focus on the 100% ones to start with. And for these guys, it's really, okay, so 4 different people are talking to it, which makes me think that it's an actual device and not just a phantom device. So typically one of 2 things happens with an unresponsive device. Either a device is configured to talk to someone that no longer exists, so we call that a phantom device, and everyone's spamming the network trying to say, hey, I want to talk to this guy. That may be a preset, it may be a device that used to exist, no longer exists. So that's about going back to the source device and reconfiguring it. Or someone's tripped over the power cord, or a device is failing and it's actually just no longer responding and it's offline. another reason you need to have a good reason to have an updated device list. So you can go through and go, wait, 50,000, that device is a weird number. That shouldn't exist, for example. I don't know if that's true, but.
The devices that starts with 191 seems like the same source is looking for it. So could be.
So this 10.30.67.24 are all being is looking for all of these 191 devices. So it's possible that they are not real devices, and that is the old configuration. The 191 devices are dead. That would explain why they're not responding. They have a tendency to do that when they're dead. So that explains those. So they're real devices, and this guy talking to them is just not getting a response because they're dead. I'm not sure about some of these other ones. If that's the case, then likely you have some kind of naming, convention scheme. So 191 is standardized, which makes me wonder about things like 1002. I don't know if that's maybe beginning with the vendor ID, so the 7s are normal. I'm not sure, but like 5,000 seems like a weird device ID. Now I'm just picking random device IDs, thinking that I think are weird. So we won't spend much more time on this because it's really about going back and looking at your list and saying, okay, is this a real device or is it a phantom device? Anything to add, Ryan?
No, I think you got it. And as always in many of these files, attack one issue, because once you get rid of one, some of these other ones reduce or get resolved on its own. So attacking them all at the same time may not necessarily be your best course of action.
Yeah.
But
especially these 3 unresponsive routers, all of those devices might be underneath those 3 routers. So if you fix the routers, hopefully everything else is suddenly 100%.
Exactly.
Likelihood low, but hopefully. Okay, so we have a reject to networks. Oh, rejections are never fun. So network 9996.
A few different devices are looking for, trying to talk to it.
So if it's rejecting it, it likely means that it knows that it is the owner of network 9996. So a router, for example, knows that it's the owner of network 9996, but it can't send its message to it right now. I love these reject reason other. Very useful. So it's all this device 10.30.67.26 that's sending the rejections to a bunch of different people that are trying to talk to it.
6726 is the destination. It's the device that got the rejected network.
Oh, right. So this is the actual rejection message. So the source is the device that's rejecting, and the destination is the device that's asking, hey, here's my message. Or the destination for the rejection message. So network 9996 is a server, thanks Mike, which means that...
Do you have the router to that network?
We'll wait and see if Mike, do you have the router to network 999? Sorry, network 9996. Okay, we will find out about that. But so multiple different devices are sending rejections, but they're all sending these rejections to the server network. Is that right?
But this is very weird. Usually there's only one. Usually one router would send reject to network to any devices that request to get to that network. But in this case, there are three different senders for reject to network.
Which means that there's 3 different devices that think they are the router for that network.
I want to be aware of saying that because we don't see duplicate networks, or maybe
Right,
just because we
right.
don't see IM router to network in this capture.
It's on a server subnet. One of the other servers is the BVMD on that subnet.
This might be a case where we need a bit more information, another capture closer to the source here, so we can see some different information to fill in the rest.
Yeah. So we've kind of figured out which problematic areas of the network, which areas of the network are problematic, and now we might have to go and I think they actually have quite a few other files and captures that we could probably look through at a later date, but
it has focused on the problem, it has focused on the area, so that's a big, big start. It's a big step in the right direction, and we can keep going down that route.
oh, I'm just clicking random things now. If anyone else has any questions about this file, let us know. There is a lot going on in it, which is always fun for this kind of thing, but also a lot of different directions to look. And so, again, why we recommend focus on one problem, fix it, and then move on to the next. Okay, so we have this other file, which we just had someone contact us with some support questions minutes before the webinar, and so they sent it to us, so we haven't seen it, or I haven't seen it. I don't think Daniel has either. So, Ryan, do you have any context for this file? I think you know a tiny bit about it.
There's a little bit. So it's an MSTP network, and apparently there's approximately 6 devices on it, and these devices are having some issues. The network has been checked in terms of wiring, so this may point us to a different direction, but if we check on some of the, there's a couple issues in here. And start with, click on the main network health score. I think we should address the first one, and the first one that we see is the duplicate source address, and this could be the source of the problem, and I'll explain potentially why.
Tell us. Okay, so source network 2400.
LG Electronics. This is potentially a some third-party BACnet device with some default addressing.
Okay.
So that should be a fairly easy one to figure out. When you see the duplicate source address, it's telling you that the MAC address is incorrect. And in this particular case, looks like it's got the same IP address.
All 3 of these have the same IP address?
Devices, yeah.
All 3.
That would be confusing.
You know, it's on network 2400.
Yeah. So basically go back to your device list. They should have prescribed different addresses and change them.
Yeah, you should have 3 different ones. So the easiest way to fix this is to go to the one that's online, change its IP address, and then if you do a rescan of the network, a second one of these should show up, and you keep doing that. And then at that point, you'll have to figure out which ones actually belong to what IP address. But that would be the very first issue to go ahead and chase.
You don't want your devices to be roommates, no shared addresses. I don't know why they let me on webinars. Okay, unresponsive device. What do we think about that?
Right.
Okay, so these same 3 are having problems probably because they have the same address.
Yep.
But they're only 20% unresponsive. How about this guy that's 100%?
Well, the same address will receive a little bit, right? It just depends which one gets of whoever first.
Yeah, so 4 out of 5. And those ones are batting 80%. But this guy, device 199, which is a weird device ID based on the other 3 that I've seen so far. But it only also, okay, sorry, let's go back. Okay, this is a 3-minute file, so quite short. But MSTP tends to show its problems pretty quickly. Only 1 packet sent.
So device MSTP device 2 is looking for device 199.
Yeah, sent 1 packet.
Let's go look at the MSTP chain.
Yeah.
Let's go see what's going on there.
So down here, actually, let's look at the round trip and just see what. Oh my gosh. Okay, so 2 to 65, 65, 66, 66, 67, 67, 69, 67, 68, not great. 68, 2, 68, 69, 69, 2.
So there's 2 cases here where 67 is trying to go to 2 different locations next with the token, and 68 is also trying to go to 2 different destinations.
Yeah.
Right.
So it looks like at some point, the token was lost from 67 to 68, and that's why 67 started sending 69.
And likely the same with 68 to 69, so it started sending the 2. Why is this one so long? Oh yeah, so 67 couldn't send to 68, so started sending to 69, and then was able to send to 68 again, and then a while later sent to 69 again, which is why you're seeing a long time between when 67 sent to 69.
Now it looks like 68, it got to 68, and then 68 tried to go to 2. Or tried to go to 69, it failed, and then went to 2, went around again.
Yeah. So 68 and 60, or 67 and 60, probably 68 and 69 are your problematic devices.
So,
which are likely could be the source address ones, maybe?
well, the source address was based on IP, so it's not likely under MSTP.
You don't think that it's the same ones that are just having problems, they're going online and offline because of that?
No.
I think a few people are raising their hands. If you guys have questions, just type them in the chat and we'll get to them.
Check the other, the standard deviation or the token passing.
We can standard deviations here.
Or the token disruption.
So the token disruptions are basically replies to pull from master.
So 65 is telling 2 that he's the next master.
It makes sense because there's a big gap there.
Yeah. But did 65 come online during the capture?
It didn't look like it. Because I think 2 was sending to, oh, sorry. 2 was sending to 65 the whole time. Yeah.
So if like if 2 3 knows 65 is the next master, 65 shouldn't be responding. He's the master.
Right, 2 should just be sending. Okay, so 2 is the main controller. Thanks, Bob. We're getting
Two is also So there's a disruption between 68 and 67, 69 and 68, 69 and 67.
Right, which we could see in the last one, so that makes sense. So basically, at some point during this capture, and we can figure out when that point is. So packet 10740 or at 18:03:36 UTC 10. 68.
68 or 67 is the master.
So 68 basically came back online.
Yeah.
68 came back online.
So the problem one would be here. 69 to 67.
So within the same second. Oh, no.
3:32.
4 seconds before, 68 went offline. 67 went, who's the next master? And 69 went, I am. Then 4 seconds later, went back to 67 after 50 trips probably.
Probably.
So it did 50 trips, and then on its 50th trip, it pulled again, and 68 said, yeah, I'm the master, and came back online. And then the same for this one. So
this is a lot later. 3:42.
Can you check the traffic?
The graph?
Yeah, how much traffic is going through this?
Which graph? Summary?
Start with the summary. So that's quite a bit of traffic, and if we check the BACnet browser, we can see who's taking the brunt of the traffic.
Ooh, 67.
So 67 is taking most of that traffic. So it's possible that it's losing the token because it's super busy, or it can't respond in the right amount of time. So you can see here on the traffic profile of what's happening.
But he's not losing the token that often because there aren't pull for masters.
It's 3 minutes.
Yeah, you're right. I mean, I guess that's a lot within 3 minutes.
Right. So I would assume one of the first things that you could do in this sort of scenario, I mean, we could get a longer capture to get a better profile of what's going on here. But it looks like 67 is doing an awful lot of work. Let's click on 67 and let's see what traffic it is.
PU type, unconfirmed requests.
So it's asking, looks like it's asking for a fair amount of data back to being our master.
Yeah, it's also COV notification.
Is 68, so he wants to know if 68 is dropping out. Yeah, it dropped out back.
Dropped out at 3:32.
So when 67 started talking to 69, so 69 responded to 67 and said, I'm the master because 68 is no longer online. So that dropped out at 3:32, and then it came back online and said, I'm the master at 3:36. So yes, it's dropping out. And 69 is as well.
Also, yeah.
So interestingly, 67, although it's doing the brunt of the work, it's not going offline. 69 are though. So that's probably right where it was.
So either way, the traffic rate's pretty high here.
Yeah.
For this type of network, so it would be good to know what the data is going through, and I would get a longer capture so we could. There's in many cases more details are going to come out, but there's a lot of reads in this network, and depending on what the capability of the controller is, that may be okay, or maybe it's being a little bit stressed. If you confirm that the wire is okay, then it's kind of points us to the controller not being able to handle what it's being asked.
Yeah, there's a lot of COV notifications, unconfirmed COV notifications that are going through a few different devices. I'm guessing they're going back to device. They're asking.
This is from 68.
Yeah, so from 68 up here to number 2. So
number 2 is asking for a lot of data.
Yeah, so
68 is sending a lot of data to 2.
Yeah, it's unconfirmed, so it's sending it to 2. So you could check the
We can see what it's sending, correct?
It's COV notifications, unconfirmed COV notifications.
But we can see the packet. Go into the frame.
Oh, sorry, I can search it fine.
So almost every second or two.
Yeah. Where?
List of values.
List of values.
63.83. And the next one.
Okay. It's changing.
So you want to look based on the specific device.
So one thing to note here is that it may be on a COV for the analog input. One thing to note is what is the read interval, right? If you're on change of value, then if your interval is set at say 0.1 or 0.01 increments, you're going to get a lot of traffic in a big period of time. So maybe to reduce this, we could look at that interval and change it a little bit.
It looks like device 68 and analog input 6 and analog input 9. That are the ones that are too sensitive.
Yeah, so right here you can see the analog input 9, and basically almost all of these are 6, 9, 6, 9. And so then we can even go in and look, let's see if I can choose the right ones, but 9 is at negative 0.009. Oops, 9. Negative point. So we don't now, again, it comes back to what we always come back to is we don't know what that is on. So if it's a iceberg that no longer exists and it's going to melt, or I don't know, some crazy thing, maybe you need that, in which case you should take it off of that network and just reduce the amount of traffic on that little MSTP network. Otherwise, you probably don't need it to be quite so sensitive, so reduce it. Really depends on what it's sensing.
Yeah, based on your application, but that's I would go back and check and see what that if you need it that often. So there you have it.
Yeah, go ahead.
That's all I was saying. There you have it.
Yeah. So we did that with 3 minutes to spare. I'm not speed talking as much as I was last time, which is good. Hopefully that was useful for you guys. There is this quick survey when you end this webinar or when you close your webinar that we'd love it if you fill out. And also, please let us know if this is helpful to you, and if so, what pieces of it were helpful, what you'd like to see more of. We are here to help you guys learn how to use Visual BACnet, how to make your networks better. I know that networking is very new to this whole world, and MSTP and IP networks can be a real headache. So we're here to help you with that. Let us know what new webinars we can do, or if you need help with your own networks, feel free to send them over to us. Thanks again, and have a good rest of your day.
Thank you.
You guys.